All right, a little bit of reading here first. So, amortization. To amortize is to withdraw or pay back both principal and interest by a sequence of equal periodic payments. So, the most common uses of this are to withdraw and pay yourself back. Okay. Best example of this is withdrawing money on a regular periodic basis from a bank account or pension after you have retired to pay yourself back the money that you have saved over a lifetime. Or you're paying off a loan. So the most common example here is when you get a car, buy a car and finance it, or buy a home, they will give you an amortization schedule, which is basically over the life of the loan, it will show you exactly every payment, every month, how much is going to principal and how much is going to interest. And what you'll see is, it's kind of scary, especially on a home loan, you'll see how, let's say you're paying $1,000 a month for your home, you'll be paying, like $950 the first month goes to interest and $50 goes to principal. And then it slowly decreases on the principal and the interest and increases on the principal. By the time you're 30 years out and paying it off, the last few months, you're paying $950 to principal and only $50 interest. The reason is they're wanting to make sure on the front end they get their money. So almost all of your payment at the beginning is going to pay the interest on the loan, not the principal on the house. So kind of scary. All right, so at age 65, you retire with $97,000. Currently, the bank pays 5% compounded monthly. Assuming you do not put any more money in, how much money could you withdraw every month until you reach 85? Okay, so a few key things to look at. You're looking at monthly. You're going from 65 to 85, so that's 20 years. Okay, here's our interest rate, our amount. Okay, so our interest rate is easy, that's 6%. Or 5, numbers are hard. 5%. The present value is the $97,000. All right, we're trying to figure out what this would be. The future value is 0 because basically we're going to borrow all of our money and end up with $0. Okay, and then it's monthly, so that's 12 and 12. Now n is going to be again that 12 times the 20 years. So that's 240. Now remember, technically this is negative 97,000. Okay, the accounting thing. But it doesn't always happen that you have to do that. And usually when you're going from here to here, back and forth, it doesn't matter. It's only when you're trying to calculate one of these two that this negative really matters. Okay? So I'm going to go into apps and finance, TVM solver. My N is 240. My interest is 5, not 6. My present value is 97,000. And again, I'm going to put it without the negative just to show. We don't know that. The future value is 0, and 12 and 12 is already ready. So I'm going to go to payment and do alpha solve. Now notice it came up negative here, which obviously it's not. So we're going to put $640.16. The 7 rounds the 5 up. So that is $640.16. Now, again, if you want to just automatically put these in as negative, it's not going to harm anything. Your choice. All right, Mr. Freeze retires with $80,000 in a 401k. So let's just go down there now and do that. I'm just going to put 80,000. Earning 5.996 interest. That's annoying, but why can't we just call it 6? But that's what it is, 5.996. That's a horrible 6. The payment we're trying to calculate, future value is 0. It does say that it is going to be monthly. Okay. So we're going to put 12 and 12. And we're doing here 12 times how many years? 10 years. So that's 120. So we're going to go back into our calculator. We're going to go up and change the 240 to 120. We're going to change this to 5.996. The present value is 80,000. So I'm going to put the negative in just for the heck of it. 80123. Payment, we don't know. Future value 0. PYCY is still monthly, so we're going to do alpha solve right here. And we get $888 even. Okay, you want to put this, that's fine, but otherwise $888 even. And that's it for lesson 5.